Hi, this is going to be a brief video tutorial on setting up the Tofino configurator software, also known as TC, and utilizing TC to find a Tofino on the network. The Tofino is a layer 2 firewall with deep packet inspection. Because it does not offer layer 3 routing functionality, this is intended for deep network security applications. So it's intended to protect critical assets and thus placing the Tofino as close as possible to a critical asset, be it a PLC or controller or a workstation or critical workstation. And for protecting more than one device, you would then utilize a switch behind the Tofino, and that switch is then connected to, say, one or two PLCs or a PLC and a critical workstation or server. So because the Tofino does not have an IP address, finding the Tofino makes it a little bit more tricky. And the way that the TC software works is it utilizes an IP address or a pingable device that is behind the Tofino. So in this case, what we have is we have a device with a 192.168.1.1 address. And okay, 1 second. Let me change the IP address of my PC. Okay, so I've changed the IP address of my PC to 192.168.1.99, so as a result I can ping the 1.1. The 1.1 is a small PLC that talks Modbus TCP, and we're going to utilize it for this example. I could also ping a switch as long as it's managed and has an IP address assigned to it. I could also utilize that as a discovery device. So knowing that we have now an ongoing ping, I'm just going to let this resume, and we're then going to start the Tofino configurator software. So during the installation of the Tofino configurator, you will be asked to create or enter a license activation key. The license activation key is something that is included with every purchased Tofino. It is I believe somewhere around a 12 or 15 alphanumeric key that unlocks the software. If for some reason you require any assistance in procuring such a license activation key, please contact us at Belden. So first off, you'll be given the option to create a new project, which we're going to do. We're going to give this new project a name. We're going to call it Test. You can protect this project through the license activation key as well as a password. So not very secure. We're going to protect this with a password called password with a capital P. And not sure why. Oh, it must contain a mixed, okay, we'll call this password 1, a mix of case and non-alphanumeric numbers, so we'll call it password -1 and a password -1. I have the option of using an admin password if I want to create a backup copy. In this case, I don't necessarily want to do so, so we're going to continue. And we're now shown the home page for the TC software. You'll see here that the project name is called Test. I can give it a company name, Belden. It's currently protected through the license activation key and the password. And you'll notice under Tofino security appliances, there are none listed. And what we're going to do is we're going to start out with the discovery process of a Tofino. So the discovery process, as mentioned previously, utilizes a device that is behind the Tofino. And effectively what happens, in layman's terms, is a packet gets sent from the TC software to the target device, and as it passes through the Tofino grabs this because it has a special added bit to it that the Tofino can identify, and it will then respond in acknowledgement. So what we're going to do is we're going to scan for this Tofino, and we're going to utilize this 192.168.1.1 address of that device, and we're going to start the discovery process. And you'll notice here that the Tofino has been discovered. So this Tofino, let me expand this. This Tofino has every possible loadable security module on here. Typically what you will see, the default that is available from us is going to be the Net Connect as well as the firewall. The event logger, Modbus enforcer, anything that says enforcer behind it does deep packet inspection. So these are all extra add-ons during the time of purchase. If you only say bought the Modbus TCP enforcer and at a later time also needed Ethernet IP on the device, this can be added at a later time. So right now, up here at the top, you'll see the MAC address of the Tofino. You can give it a name. A description as well, and so on and so forth. This will allow you to discern this Tofino from other Tofinos that have been found on the network. You'll also notice that the communication that we're going to have with the Tofino is going to be feasible both via USB and via the network. What this means is that if I would like to configure the Tofino only across the network or only through a USB, I would be utilizing sneaker power to transfer the configuration via USB from the PC that's running TC to the Tofino, load it onto the Tofino. The Tofino will then put a signature on there saying that yes, I have this. You then plug it back into the PC. You would then verify this, and it is a little bit of a pain to do so. So utilizing the network comes in very, very handy, and there are certain instances where you do need to utilize the USB or where there are benefits of utilizing the USB to obtain the syslog information from it in order to parse it. Below this you'll see the contact asset. This is the PLC that we're currently utilizing, and here are my two network names. The silk screening on the device itself has network 1 as pretty much the unlocked port, so we're going to call this the public, or we can also call this the plant network. And network 2, this is the protected port, and we can call this the asset. So because this is an RJ45 port on both of these, I can dictate the speed and duplex on this on these ports. And you will also notice here that under status, the Tofino is currently showing as it being in test mode. So the Tofino will allow any and all data to pass through, as you can tell by these pings that are currently going on. The Tofino is also going to send a syslog out for anything that it has either not been whitelisted or anything that has not been blacklisted. So the objective behind the Tofino is that you account for every traffic that is passing through the Tofino that the PLC or the critical asset would typically hear. So the firewall rules are going to be set so that the critical asset will only hear what it needs to hear and nothing else. And this is what we're going to do once we get to the firewall rules. So here are all the different statuses. We'll show this once the Tofino has been given its first configuration. We then also have the syslog server IP address. And what we're going to do here is we're going to put the IP address of my PC, oops, and I do want to show syslogs. And once this gets pushed out to the Tofino, then we're gonna start seeing the syslogs here shortly. So the next thing that we then have is firewall. This is where all of the firewall rules are entered. Creating a firewall rule is really simple. One of the first things though that does need to take place is, because we're going to configure the Tofino across the network, we need to have an ARP rule. And you'll see up here that no ARP rule currently exists. I could either manually create one, or I can simply click on this and one will automatically be created. And what this means is that any ARP from the plant in either direction to the asset, or the asset to the plant, if it's ARP, it's going to be allowed to pass. So once we have that rule, we can then create another rule. I'm going to create another rule, and from here I can either put in the IP address or the MAC address of the device that is going to initiate the communication. Because IP addresses can change on the network, and especially if you have a lot of firewall rules, it is very difficult to then have to go through all of these firewall rules and redo all of the IP addresses that have changed over time. So it's significantly easier to go into assets, and you can then either create an asset or also detect assets. Detecting assets only works once the initial configuration and the ARP rules have been pushed out to the Tofino. So in this case we're going to forego that, and we're going to manually create a new asset. And in this case it's going to be my workstation. It is a computer. Manufacturer is a Dell. Model, we're going to omit that, and its IP address is 192.168.1.99. I'm going to omit the MAC address. Obviously the benefit of detecting assets is that the MAC address will be provided, and this way the likelihood of fat fingering a MAC address when entering it manually is diminished. So in this case we're going to click finish, and we have our first asset. We're going to create another asset. In this case it's the Wago PLC, and it is a controller, and it's made by Wago, and its IP address is 192.168.1.1. And as you can see here, I now have a list of assets. This list can be as short as you want it to be, or as intensive and extensive as you would prefer it to be. The benefit of creating a list of assets like this is that any time that there is a change of an IP address or a MAC address, it's a lot easier to change it here and then have it reflect in the firewall rules. So in this case I'm going to create a firewall rule where we were earlier. It's going to be a standard rule, and here we have our assets, and in this case it's going to be initiated from the workstation, and the target is going to be the PLC. So the communication is going to start from the workstation to the PLC, and what I'm going to do is I'm going to create a rule for ping. So this is going to be ICMP ping, and I'm going to block this ping. So the ping that we currently have going on down here in the corner, I want it blocked. So we're going to go from the workstation, initiate from the workstation to the Wago. Hence, because it's initiating from the workstation, it's going to the Wago, and it's going to utilize a common IT protocol for ICMP ping, and I'm going to deny that ping. And the next rule that I'm going to create is I'm going to create a rule for monitoring, or allowing me to monitor the Modbus TCP traffic. So this is a little HMI simulator. It is reading information from the PLC. So as I manually increase the pump speed for the drainage, you'll notice that the PLC is increasing this pump to keep this tank level. So what I'm able to do is I am able to change this value, this new set point on the tank, and I'm able to invoke a write command to the PLC. So you can see here that the PLC has sped up the pump to its maximum in an attempt to ensure that this tank level maintains this 800 liters capacity. So I can also then reduce the speed of this pump, and as we get closer to this 800, this pump here will slow down. You'll notice here that I'm hitting 800, and this pump will now slow down in an attempt to maintain this level here. So there's bidirectional communication taking place utilizing the Modbus TCP protocol. I can write and read information. So what I want to do is I would like to create a firewall rule that is only going to allow read commands. So I don't want this this device, this workstation, to be able to go in and create a potentially critically high tank level, because when I create this critically high tank level, what happens is that I can spoof this so that if I create a 900 liter set point, this pump here is not going to speed up or slow down fast enough, and I'm going to overflow this tank. The alarm that you're hearing is the set point having been exceeded. Let me turn this off. And again, it's a way that I can keep this tank at a safe level, that being the 700 liter level. So again, I just want to make sure that I can read information but not necessarily change any values in this. So what I'm going to do is I'm going to create another rule, and it's going to be a standard rule. It's going to come from the workstation to the WAGO, and it's going to be a common industrial protocol, and it's going to be for Modbus TCP. And instead of just denying it, because I still want to be able to read information, I want to use the enforcer. And what the enforcer is going to allow me to do is the enforcer is going to allow me to have read-only communication. If I wanted to, I can get this far more granular to specific coils and registers and records, and even down to the, let me find one, even down to a specific address level. So it's far, far more granular than anything that a typical firewall would offer. And also, because the Tofino does not use signature-based firewalling, the Tofino utilizes instead a very comprehensive understanding of the protocols themselves. So thus, when a new vulnerability is discovered, the Tofino does not need to have a new set of signatures loaded upon it, very much like what antivirus does. So if there's a new vulnerability discovered for an antivirus application, you have to have new antivirus definition files loaded. This is very similar to what a signature-based DPI firewall would utilize. Because the Tofino is protocol-based firewalling or protocol-based DPI, it always has an inherent understanding of that, which is also why it offers a sanity check. The sanity check verifies that the protocol really is Modbus in this case, or Ethernet IP, all depending as to what the firewall rule is that's been put in place. And it verifies that this protocol really is that it has not been tampered with, that it is not corrupt, and it is a great way of ensuring that the communication that is going through the Tofino really is that protocol. So in this case, I'm going to leave sanity check enabled, and I'm going to do a read only. So with this read only, I should then still be able to read information from the PLC, yet not change any values for its tank level. So with this, the next step that we're going to do is we're going to go ahead and we're going to go out and apply this rule. And this rule, we're going to push this out to the device. Let me make sure that I do have the Modbus TCP enforcer enabled. Yes, I do. And we're going to call this test. So the very first push of the configuration to the Tofino, again, we're utilizing the device behind the Tofino. You can see here via the 192.168.1.1. The reason that this takes a little longer than the second and any subsequent pushes is the fact that the Tofino creates an encryption key for this configuration, so that this project file will only work with that Tofino. And if for some reason this Tofino were to ever fail, what one can do is one can replace the Tofino and simply change the MAC address of that Tofino to swap out a device. So the encryption key also does prevent someone else from trying to create a new project and pushing a new configuration out to the Tofino. So in this case, what we're going to do is we're going to go ahead and speed up the video. And here we can see that the Tofino has successfully accepted the configuration. You'll also see that the successful notification. You'll also see information back from the Tofino, its firmware and everything else. This is the same information that you will then also see or have seen here. So this is the project revision 2. It's created by me. I'm going to click on OK. And at this point, because it's still in test mode, I can still read information, changing the speed of this pump manually here, and I can also change this set point. So it accepted that set point, and you'll also see that these pings are still ongoing, so there's been no interruption in any of the communication. So it's a great way of providing a set of firewall rules to the Tofino with zero impact. And because this is currently in test mode, these firewall rules are now in place in a test mode, so that anything that violates those rules or anything that has not been accounted for is now showing up in these syslogs. These syslogs can be collected. We also have an Excel parsing tool. Our tripwire division also has a parsing capability that helps in the parsing and normalizing of these rules. Their application is called TLC. It's the Tripwire Log Center, and it can also receive all of these syslogs and then parse them down so that a lot of the repetition that you have in here is then consolidated for easy firewall rule creation. What's also really nice about this is that within this, you can right-click on a event, and you can suggest a rule from this event. So in this case, the protocol that's causing this alarm or this notification is the LLDP protocol. I believe this is one of our switches that I have on our network, and it's sending out LLDP packets. So obviously the PLC does not need to hear this. And what I can then do is I can then block this so that the PLC does not receive this. And once I block it, this notification or this alert will no longer show up. And the objective is that, again, you account for all of the traffic. You either allow it or actively block it. And at that point, once you've accounted for everything, you should not see any alerts showing up in syslog. And any subsequent alerts that you do see will be a network event. It could be an intrusion detection. It could be that a device has just not been accounted for, and so on. So again, we can see here that communication is taking place in both directions. And what we're now going to do is we're now going to change the operation of the Tofino from test to operational. And I'm again going to go ahead and apply this. So it's going to push the configuration out via the device behind it. The Tofino is going to grab this configuration. And what we're going to see here in a second is once this, the configuration has been accepted, my pings will stop, yet the communication, the read communication from the PLC will continue. As we can see here, the pings have stopped. It's still reading information from the PLC, yet because it is a read-only rule that we've applied, I will not be able to set a new set point within that PLC. So it's a great way of blocking traffic, allowing traffic, and accounting for everything that's on the network. So I hope this has provided enough information for you to do some initial testing. Again, if you have any questions, please do feel free to reach out to us. We'd be more than happy to help you and assist you in any way possible. Some last pointers would be some of the protocols. We have common industrial protocols for BACnet DNP3. DNP3, we have a deep packet inspection enforcer. So anywhere where you see this little orange dot, this is actually a lock, is where we have the enforcer. So we have an enforcer for DNP3, Ethernet IP, explicit. We have a enforcer for Goose, for IEC 104, for Modbus TCP, as well as OPC traffic. There are a slew of common industrial common IT protocols to account for everything. There's typically a ton of NetBIOS traffic on a network. So again, it allows us to account for that. And then we also have vendor-specific protocols. So with the vendor-specific protocols, for example, we'll pick Rockwell. We have a bunch of specific protocols, and we also have asset templates for devices themselves. So looking at, say, a Control Logix EN2TESC, you'll see here that there are firewall rules already in place and created for this. So again, you'll notice the recommendation: if you want to make any changes to this read-only element, do make a copy of it. And these are available for a variety of other vendors that are out there. So again, feel free to reach out to us if you have any questions, if you need any assistance. And in the meantime, thank you so much for watching, and have a great day.